Hey folks, thanks so much for joining. We're going to give it another minute or two until everybody hops on the call. Okay, cool. Looks like we've had a few more folks join in, so we're going to go ahead and get started. So good morning, good afternoon, and good evening, folks, and welcome to today's CircleCI Container Runner webinar session. My name is Derry Bradley, and I'm a solutions engineer here at CircleCI. I've been with the company coming up on just about a year now and working in the space of software delivery for just over 3 years. We can see on the screen here my contact details. So if there's any questions or anything like that after the call, feel free to reach me at this email address. And again, I'm very excited to speak to you all today about Container Runner. And I have a couple of goals that I'm kind of hoping to achieve in today's call. And the first one is that you all walk away from here knowing the problem or the limitations that we're trying to solve with Container Runner. And I think if y'all understand this, then you'll all be able to clearly understand who we built this technology for, which I'm sure is some of you on the call today. And then this might sound a little bit obvious, but exactly what Container Runner is, and then being able to define that in just one sentence. But before we get into a demo, I do think it's very important that we understand what Container Runner is, what it does and what it doesn't do. And to understand this, I'm going to start at the very beginning with a very quick recap of what self-hosted runner is, or I guess what self-hosted runner was. This will then lead me into some of the limitations that Container Runner is now here to solve. And then finally, in one slide with one sentence, exactly what Container Runner is. And with this one sentence, you'll all be equipped to kind of spread the word that Container Runner is here and also exactly what it is. We'll then have a quick demo where we will see what Container Runner looks like when it's in your cluster and what it looks like when a job is configured to be executed with this runner. We're then going to have some time for some Q&A, so feel free to drop questions in the chat as we go, and I'll be sure to answer them all at kind of the end of my segment of the session, because whatever time we have left, I'm going to pass it over to my colleague Benny, who's here to give us all kind of a surprise feature preview that we're releasing in the coming weeks. So let's kick it off with that quick recap of self-hosted runner. So looking at CircleCI's hosted compute today, we basically have two types of executors. We have that machine executor and we have a Docker executor. And with our machine executor, you get a dedicated machine for one of your jobs. And with that, you have access to the following architectures: Windows, Linux, ARM, and Mac OS. And what's great about CircleCI is that on our hosted compute, we also enable you to kind of scale the size of these executors in terms of CPU and RAM. So between the different underlying architectures and the different sizes of instances available on our hosted compute, we do offer an umpteen amount of execution environments. But if we just take a step back and think about that at a super very high level, on cloud, we basically have two executors. We have machine and we have Docker. However, today, the vast majority of our compute consumed on cloud comes from this Docker executor. And this is simply due to the fact that engineering teams across the board are moving in this direction. The Dockerization and containerization of the Dockerization and containerization phenomenon is taking over the industry, and it is everywhere. And they're basically so popular because they make our lives as engineers much easier. So what is Container Runner? Basically, or what is Runner, I should say? It's basically our flavor of a hybrid offering that targets engineering teams that need to execute some sort of job on their own infrastructure. And this can be for whatever reason, but it's mainly due to some sort of security or compliance reason. And the benefit of this model is that customers can still take advantage of CircleCI's system, all the goodness through our UI and all the features that come with kind of our hosted model or our cloud model. It's just the compute itself of those individual jobs that need to be executed on your own infrastructure that is executed on your own infrastructure. And with this self-hosted kind of runner model, customers can execute jobs on Windows, Linux VM, ARM, and Mac OS. And I guess today, if you kind of think back to how our compute works in our CircleCI hosted compute model, there are basically two types of executor. Mirrors our cloud's machine executor. So going forward, we're going to refer to this model as a machine runner. So the self-hosted runner model that existed today, going forward, this is now referred to as a machine runner, and it encompasses the Windows, Linux VM, ARM, and Mac OS. And if we think of the limitation or the problem with this, thinking back to our hosted compute model, is that the majority of our customers want to execute their jobs on a Docker executor. And with the old self-hosted model, we were basically only addressing 20% of our cloud customers' needs. And what this translates to is an extremely high barrier for entry for engineers across the board if all you want to do is run the most common use case on CircleCI, which is a containerized job. Some of you on this call might already know that it is possible to run Docker inside a machine runner or inside the old kind of self-hosted runner model, which we're now referring to as machine runner, but it's just a lot harder to do, and it's a lot more work for engineering teams to do so. So a big reason why we built Container Runner, the Container Runner Docker executor, is to make it as seamless as possible for engineering teams to run containerized jobs, and also address the fact that for the most common use case for our end users does become that bit more difficult to onboard to the technology, but also to maintain the technology when it comes to security and scalability. And this leads me into the second limitation with kind of that old model, which is scalability. So if you're a DevOps engineer and you're in charge of maintaining a bunch of self-hosted runners to meet the compute demands of your kind of dev teams, if you want to run 50 jobs, basically you're going to need 50 VMs, each of which are installed with a runner. And what this usually translates to is 50 EC2 instances or 50 compute engines on Google or Azure, and all of a sudden kind of ops folks or engineers kind of find themselves managing instances when a lot of the time all you need is containers, not these dedicated machines. And I think just to follow on from that, it's very clear that engineers, developers, or ops folks, they don't need this kind of overhead. It translates to a really high kind of infrastructure management burden. And again, it makes it very difficult to adopt the technology and even more difficult to manage. So we took these two limitations and we designed a solution to address them both. And we came up with this technology called Container Runner. And Container Runner is this one-line definition that we see on the screen, the one that I mentioned at the top of the call. It is a technology that a user can install in a Kubernetes cluster, which enables them to run containerized CI jobs. It solves problem one by letting, or it solves kind of that first limitation by letting customers leverage a native Docker executor on a self-hosted model. And it solves limitation two, the scalability limitation, by taking this one container agent, installing it in your Kubernetes cluster, and then just managing this one thing. So if there's 100 jobs that need to be run, this one thing will spin up the underlying pods, which is the underlying compute in Kubernetes. So it's going to spin up those pods, execute the work as a container within those pods, and then it's going to tear down the pod. So the pods are ephemeral by nature, and all you need to worry about as an end user is that one container agent. So I'm sure you can already see how this completely reduces the operational burden, and again, that time to value for engineering teams. And it's this time to value that was the real driver behind us kind of looking into and producing this technology, as we know the importance of it when it comes to delivering software successfully at high velocity, as that can be a differentiator between us and our competitors. Just another piece on that kind of scalability, that scalability segment, is that container agent auto scales in the sense that when there are jobs that need to be executed, it's going to spin up a pod and it's going to execute that job in a container within the pod. And it's then going to clean up when the job is done. It's important to kind of highlight and to note here is that it does not scale the underlying compute itself, and the end user must do that themselves. So with Container Runner, we did not want to go into your cluster and start kind of scaling the underlying compute. Most customers do not want us to cross that line, and there will be reasons, because there are reasons why you all want to kind of execute on your own infrastructure, and you don't want us coming in there and start kind of mess around with the underlying resources that your Kubernetes clusters are running on. I guess it's also kind of important to note that the two limitations that we discussed, they are kind of issues that customers have gotten around before. However, we did notice the burden that engineers undertook to kind of get around these limitations to execute those containerized jobs in a self-hosted way. We saw how it affected engineering happiness and definitely engineering productivity. We also noticed the time that it took for engineers to get around these two limitations. And with the release of Container Runner, we have now, I guess, acted on these kind of observations. Because look, we're all engineers on this call, we're all innovators. If we want to run containerized jobs and self-hosted compute, we're going to find a way to do so, no matter how long that it takes. And this is basically why we ideated and released Container Runner. And our main goal with the product is to reduce that time to value when using self-hosted compute. And this is extremely important to us as CircleCI, as we seek to enable engineers and engineering teams to operate above the value line by as much as possible, kind of maintaining and scaling your build environments and enabling you and your engineers to focus on both ideating kind of applications and then revenue generating technology, both of which are aligned with the goal of delivering value to your customers faster. And with Container Runner, it changes the model for how it operated to be more scalable and also more container developer and engineer friendly. So if we think back to our cloud model for just 1 minute, we kind of brought parity between the cloud and self-hosted kind of model, where on cloud it's Docker executor and machine executor, and on self-hosted runner it's Container Runner and machine runner. So cool. I guess now we're at a point where I hope we understand a bit of what the technology is. And the scary part might be then, okay, well, how do we get this going? Some good news is that once you configure your cluster to allow outbound connections on port 22, the installation process is actually a piece of cake. And I can promise you this, as I've gone through the process multiple times on multiple EKS clusters, and also actually on my own local Docker desktop. I guess we all know painful installation processes, but as a fellow engineer, I can assure you that even I was pleasantly surprised with how quickly I was able to execute Container Runner on my own private EKS cluster and then watch jobs being executed in real time in the CircleCI UI. So the first thing that we need to do is create a resource class and a resource class token, and we can do so on the CircleCI web app or through the CLI. The next thing that we need to do is install the Helm chart with the release name container runner, and we can update the values.yaml with a resource class name and a resource class token, which I'm going to show you very shortly. All of the Helm chart parameters and the Kubernetes permissions that are needed are available in our documentation. And if you want kind of that custom pod configuration that we spoke about, you'll also do so in the values.yaml. And again, the documentation is all going to be shared with you after this call. Finally, once the Helm chart is installed, all you need to do is start configuring jobs and triggering jobs to be executed on your kind of resource class container runner. Before I jump into, I guess, a quick demo of how Container Runner can work, I just want to have a quick shout out on how you can build container images with Container Runner. And I guess let's just take a quick step back. Some of you might already know that you can build Docker images on our machine-based runner today by just having Docker itself installed on the base OS. So this is kind of point 2 here. You can still totally go ahead and do this if that's what you want to do. However, we're also kind of encouraging point number 1, a tool kind of like Builda or Kanoko. And that's because when you put Docker into a container via machine or kind of container runner, you will run into some security issues. Basically what I'm talking about is Docker and Docker or DIND here. And this requires you to pass the Docker socket to the container if you want to be able to build those Docker images. And doing so is a security issue. Basically, if a malicious actor were to get access to that Docker socket, they can basically do what they want with Docker. So in theory, if somebody accessed that one container, which was supposed to build Docker images inside of Docker, they would have the power, to example, to kind of shut down all the other containers running as they have full access to the Docker socket. And it's for reasons like this that we do not recommend DIND, as it is that security risk. You can still totally do it, and you can do it on our runners if you want, but it will totally break Kubernetes RBAC controls. And that's why we're introducing, well, that's why we're kind of recommending these kind of safe ways to do so with Builda, which is a Red Hat product, which allows you to build containers without access to root, or another Google or another project called Kanoko by Google. And we have some pretty cool documentation in our public docs with how you can get up and running on these tools. Personally, I've been playing around with Builda quite a bit, so I would recommend having a look at that. I think it's really cool. It's really smooth. And again, our documentation will show you how to get up and running with Builda. So that's kind of my presentation of the problem of, I guess, the limitations of why we ideated Container Runner, what Container Runner is, and some little kind of tips and tricks with kind of building Docker images on Container Runner and how to get it installed. So I'm going to jump into a quick demo. And to begin this demo, I'm going to bring you to our Container Runner documentation. And here you're going to get a clear overview of kind of what Container Runner is. And you're also going to get kind of some other cool snippets, how it works, how to get set up, etc., etc. Again, this is all on our public docs page. You can see the URL at the top of the page, but this will be shared with you all at the end of the call. So what do we need to do to see a Container Runner execution? So I'm going to jump into our kind of container or into our self-hosted runners tab on the CircleCI web app. And the first thing that we need to do is create a runner resource class. And in order to do this, sorry, before I jump into that, in order to do that, we first need to create a CircleCI namespace and just a clear definition. This is a CircleCI namespace, and this is a unique identifier that's owned by a given CircleCI organization. And all of your self-hosted runners are going to live within this namespace. So we can see that my namespace, or that my organization, is called Stone Monkeys, and my namespace for this Stone Monkeys organization is DBCCINS. That's Derry Bradley CircleCI namespace. And I've no doubt that you're all going to be able to come up with a much nicer kind of namespace title than mine. But however, that's the one that I chose at the beginning, and fortunately I'm kind of stuck with it, which is a good point for you all to kind of take note. It is, we do kind of recommend that you stick with your organization name. So that's why when I jump into create resource class, it kind of it prompts me with my organization name. But all the runners that we see on this screen here, they're going to live under my namespace, and that namespace again is tied to my CircleCI organization. Just a quick note: if you're already using orbs, or if you're already creating your own orbs, that namespace that you've created to where you store those orbs, your self-hosted runners are going to live here also. So just to kind of point that out to you all. So once we have a namespace created, we're going to create a resource class. And this is basically just a label to match your CircleCI jobs with a certain type of runner. So the first part of your resource class label is going to be that namespace name. Mine again is DBCCI namespace. So I can call this container runner for my mobile apps or something like that, or container runner deploy, for example. Okay. And this again, kind of these resource classes, they just enable you to identify your runners, which will allow you to write your config, which we'll see in a minute, to send these jobs to specific places. If I hit save and continue, it's gonna present me with a resource class token, and I'm not going to show that simply due to the fact that we don't want to share that out with kind of the public. You want to keep these kind of safe. So I'm just going to jump back over to the self-hosted runners tab for a second. And what we can see here is that we have a little plus sign. For example, this container runner webinar, and this will give you information with how you can install this runner in your Kubernetes cluster and get up and running pretty quickly. So let's assume then that you've updated your values.yaml. And again, there's documentation on how to do this. It's very clear within kind of our documentation. Let's assume you've updated that values.yaml that is associated with your Helm chart with that resource class token. Let's assume you've then authenticated into your Kubernetes cluster. What we're going to do then is we're going to run these following Helm commands. These Helm commands that we can see on the screen here now. And that's kind of to install that runner in whatever namespace that you decide in your Kubernetes cluster. So if I jump over to my terminal here now, I'm just going to make sure that I'm still authenticated in. This is just, yeah, so what we can see here is that this is just kind of a short for Kubernetes get all. And we can see that I'm authenticated into my DB cluster CCI, which is running in EU West 1. So if I'm going to go for I'm going to do a Kubernetes get all on the namespace CircleCI. So in this namespace, what we can see is that single pod with the container agent. And just to be very clear, the product is container runner, but this container agent is what's monitoring CircleCI for jobs that have been configured to execute on it. So that's been running for 4 days or so in that namespace in my Kubernetes cluster. Let's jump into my config. And what we can see here now in this example is that I have a build job, I have a test job, I have a couple of deploy jobs, and also an internal security scan. And let's just say for security and compliance reasons that I have to run my internal job, my internal security scan job, and also my deploy jobs on kind of my own self-hosted infrastructure. What we can see is that the build job and the test jobs, they're configured just to be executed on CircleCI's kind of hosted compute. So we provide the Docker image like you have done a million times before. In our deploy to EKS job, what we can see is we're also providing that kind of same Docker image. However, we're configuring these 3 jobs to be executed on this resource class DBCCI, which if you'll remember is my namespace, and that container runner webinar container runner or self-hosted execution environments. So that kind of resource class token here corresponds to this resource class token that we saw, or this resource class, sorry, that we saw in my self-hosted runners tab. So if we kick off a build here, jumping back in, I'm just going to do a git commit and allow empty commit. Container runner webinar, and I'm going to do a git push. So let's just make sure that that has kicked off in the UI. Excellent. We can see the workflow is kicked off and the build job is underway. And there's a dependency matrix in this kind of workflow where the build test job requires the build job to complete, and so on and so forth. What we should notice in our Kubernetes cluster, however, if I do that kubectl kind of get all again, is that at this time, no jobs have been configured to run. And that corresponds to what we see in the UI as nothing has kicked off. But these 3 jobs, they're configured to be executed in that Kubernetes cluster. So let's see if it's picked up anything yet. Okay, great. So it's running 1 job, right? So this job, I imagine, corresponds to our internal security scan. And let's just wait to see what happens here. So now the deploy jobs have kicked off. Let's just clear the screen so it makes it a bit nicer to see. Great, we can see that these pods have been spun up. They've executed jobs as containers within those pods and are already in a terminating state, kind of, I guess, showing the ephemeral nature of those pods. Because they're in a terminating state, I can assume that the job has completed, which again, we can see corresponds to what's going on in the UI. I just want to highlight a couple of things here. So now that we've seen kind of the jobs spin up in the Kubernetes cluster, we've seen how they've been terminated, we've seen that ephemeral nature. I just want to show a couple of things here. We can see in the testing job that this has been executed, or this has been configured to execute on our cloud executors, on our kind of CircleCI hosted compute. And if we jump back a screen, if we jump into this internal security scan, we can see that this executor is that kind of container runner in our self-hosted Kubernetes cluster. One last thing I want to point out, I believe we can see that this job kicked off before, which tells me that's probably that internal security scan job. And we can see that the pod name ends with this kind of S5J or M53. So if we want to kind of get some information to debug that pod or get information about the execution environment itself, we can jump into this first task lifecycle step. And for this job, we can see that was configured to be executed on this pod. So for debugging purposes, if you want to jump into your Kubernetes cluster and start getting information about logging, this is where you'll get information about the pod that job was executed to be configured on. So I hope that you all got kind of a flavor of, a container runner job executing in that Docker execution environment in a self-hosted Kubernetes cluster. I do know that this is a very basic demonstration, but I hope it gives you all like a flavor of how Container Runner works, and then how you can all use it to execute Docker jobs in a scalable, maintainable, and secure fashion in your own Kubernetes compute. So I'm very excited to pass it over to Benny, who has a really cool feature, which I think a lot of people on this call are going to be very happy to see coming in the very near future. So Benny, I'll pass it over to you.
Thanks, Derry. Hi, everyone. I'm Benny, and I'm the product manager for the developer experience team. It's very good to be here. Just before we start, once again, if you have any questions at all during this presentation, feel free to drop them in the chat and we can answer them at the end of the session. So the developer experience team is a relatively new addition to CircleCI. Our mission is to accelerate developers where they spend most of their time. And I think in the case of 99% of developers, we know that this place is the IDE. For this reason, the first product that we've been working on as a team, and which I'm very, very pleased to present today, is the official CircleCI VS Code extension. So I thought I'd come here and give you a little preview of what this extension entails. So we built this extension because it became evident to us that today developers are forced to live their developer environment, even just temporarily, in order to get value out of their CI. So for example, when they want to go and check if their workflows have succeeded, they will have to go on the CircleCI web app and look at whether the pipelines passed, or go on your GitHub or GitLab or whatever VCS you're using to go and see if you have like a green or a red mark. And similarly, we know that when editing configuration files, specifically in our case for CircleCI, they have to continuously move back and forth between the IDE and the documentation page. And this context switching has a lot of impact on developers' ability to focus, and therefore we think on productivity. So what we want to do with this extension is we want to give developers the tools to manage the CircleCI pipelines directly from inside VS Code. And we want to make it much easier to create, edit, troubleshoot, and optimize their CircleCI YAML files without having to constantly go back to the docs. So I thought I would give you a little demo of what the extension entails. So let's switch to VS Code. This screen might look familiar to some of you. So you can see here on the left, we have a CircleCI icon. And when I open it here, I see a list of pipelines. Now, hopefully this looks a little bit familiar because it's supposed to mirror the pipelines view that you have today on the web app. So what I can do from here is I can look obviously at pipelines, workflows, and jobs. So I can drill down as much as I need, and I can go and get all the information that I need in the moment. So for instance, I might want to go and look at my tests and see which tests passed or failed. I might want to go and download my artifacts directly from the IDE, so I can do that from here. I also can interact with any of my jobs and workflows just in a very standard way. I can like open them in the browser. I can decide, for example, to rerun a workflow or to cancel it. And I can also, there we go, it's cancelled. I can also decide to approve some jobs that are on hold. So I'm going to do this now. So I can do this directly from here, which makes it a lot easier to notice when an action is required on my part while I'm continuing to develop on my project. We have introduced notifications so that for exactly this reason. So if a job failed unexpectedly, knowing about it immediately is going to improve my ability to act on it as soon as possible. So here, for instance, I see that my workflow has failed, so I can go and have a look at what happened, and I can have a look here. And you might also have noticed that here, quite visibly, it's telling me that my most recent workflow has failed. Now, as I open the project, all of these pipelines were loaded automatically based on my project configuration. So I have a YAML file, which tells me which project I'm working on. But if I wanted to change this configuration, I could always go on my settings, excuse me, and for instance, select a different CircleCI project, or decide, filter out which information I want to see. For instance, I might want to only see my pipelines or only follow the current branch I'm working on rather than all branches for the project. And I might, for instance, not want to see the success workflows. So you see, I only have everything, all the things that need attention now. And in the same way, I can configure my notification. So it's nothing new, but it's a new way to interact with CircleCI that allows everybody to be able to do this from their local environment. So I really hope that you guys are as excited as I am for this feature. There's a second set of features that we have developed that is perhaps a little bit more subtle, but I think also can bring an incredible amount of value, especially to all of you who have worked on YAML files in the past. I think you will have, and I've experienced that it's not always the easiest thing to know whether you're using the right syntax or not. And so here I have just a standard YAML file. And even just at first sight, I think you notice that it's a little bit easier to read it than it normally is. Just for comparison, I'm going to show you what it looks like without the VS Code extension installed. So this is exactly the same file. And we have introduced syntax highlighting, which makes it easier to detect you to understand which parts of the file I'm looking at. So distinguish variables, parameters, etc. I'm going to run you through a few of the features that you can expect to find, but it's really, there is a lot of stuff in there that you'll just discover with experience. But for instance, we have one of the main things we've added is contextual documentation. So when I hover on a key or a parameter, the extension is going to propose some documentation information to me with a link to the official docs in case I needed anything more. You see here that I have some warnings. So for instance, here I'm warned that my job, I've declared it, but I have not used it yet. And here it's letting me know that there is a newer version of this orb out there that I might want to consider using. Equally, we have introduced some usage hints. So here, we suggest perhaps using a key store test results so that you can get the most value out of CircleCI because you'll be able to visualize your tests. Some other cool things that we do is we validate the syntax to give immediate feedback. So let's say that I didn't have any steps here. It's going to tell me that I have a little problem, and I can, let's say that I didn't have the test steps at all and I want to use auto completion. It's going to recommend to me to use steps, and then I can call auto completion again to get a suggestion for the most commonly used steps that I probably want to pick from. Auto completion is available in many situations. I'm going to try to show you a different one. Well, here I have a dynamically defined parameter. And so here, if I wanted to use auto completion, I could just do this, and it's going to go and find which parameters options I have defined, and I can choose parallel level. Now, when I'm using jobs, we were looking at definitions before. When I'm using jobs, well, once again, I have, sorry, auto completion that suggests to me the jobs that I have defined above. Syntax validation, once again, so it's going to tell me that I made a typo in this case. And also we have introduced go to definition. It's perhaps less visible as a feature, but I think it's incredibly useful. So I'm going to right click and select go to definition, or there's obviously a shortcut that many of you know, to go and have a look at where my job was defined. So if I have any doubt about what, I don't know, parameters my job expects, I can go and have a look here. Let's say, for example, I want to look at what type parallel level is. So it's taking an integer, and now I'm going to go back, go to where my job is used, and I see that here I have correctly entered an integer, but if I had, for instance, put a string, it would flag it out. And this system of rich navigation through this go to definition and go to reference approach is useful for very large files, obviously, but also for smaller things. For instance, I can use it here and it's going to show me exactly what parallel level is, but also for orbs, which is quite new. So if, for instance, I want to go and have a look at the definition of this orb, I can do go to definition. Once again, the extension automatically downloads the definition of my orb, and I can have a look at everything I need here. This obviously also works just staying within the same file. So let's say that I wanted to see which one is the default version, and just click Control and hover, and it's going to give me all the information I need, and same thing here. Yeah, I think this is a kind of a good overview of what we offer. There's many more things, but you'll be able to explore it yourself, hopefully very soon. So getting back, I think down to some practicals. I'm sure many of you are excited to try this. I hope so, at least. So the extension will be available for free on the VS Code Marketplace in November. We will first do a little soft release. So if you'd like to be notified about the preview, you can drop us a message in the comments, in the chat, and we'll make sure to notify you as soon as it's available. Here is mine and Derry's contact details. Reach out whenever. Yeah, once again, thank you very much for attending the webinar. I think I hope you're walking away with a better understanding of what Container Runner is and a bit of excitement about the new VS Code extension. Thanks again, and I wish you all a good rest of the day.